All right, guys, apologies for the wait. Yeah, just had to get a few things in order. Um, and then I just need confirmation that you all are able to hear me. And yeah, that, yeah, we can hear each other throughout. Okay. Are we fine so far? Can I get a thumbs up or something like that? Can you all hear me? Okay, beautiful. Thank you so much. So as promised and as I indicated, we're gonna do things this way today. I just wanna wrap up on sequences and series. It's quite an important topic. So um, I thought I should maybe do questions which are a bit challenging, let me say that, or maybe not challenging. You might be scared when I say that, but these are questions that are often a bit out of the box, out of the ordinary. And so I think if we go over this, I wouldn't want to avoid this. Um, so just make sure that you understand every little thing that we can do. You would have noticed I don't like just doing things and throwing things your way. I actually prefer giving you a background, a context to say, this is why we do this is why I do it this way, so that at least when you get to revise and even maybe review these videos, you can also be in a position where you're like, oh yeah, I remember this, why I have to do this. This is what I refer to as conceptual understanding. When you know why something is done the way it is done, you get a good grasp, understanding, solid understanding of the concept. And I was talking to a group of students today again, and I said to them, one of the things you need to do and get accustomed to is researching, finding a history of something before you do it. Okay, so and I so wish that you would actually get to that point where you, when you learn maths, in your learning of mathematics, you become so deliberate and make sure that you actually get to understand why things are being done the way they are done in this subject. Okay, so very important. Don't feel like I'm wasting time or something like that, but I really do this purposefully to help you so that you can have a better understanding of the subject. All right, so let's get to it. One of the little things that we're going to start with today, I don't know how many of you have heard of this or are aware of this, but this is what we will refer to as a mixed sequence. Okay, we're going to start off with a mixed sequence here, or a mixed series. So these are things that these are type of questions that are not so obvious, as I said, but today we're gonna try and make it a bit obvious. All right, so let's get the writing pen here working. Okay, there it works. Let's select another color, increase thickness. Okay, so I've got a series one. Oh, I think that's too thick now. Why not? Yes, let's try it again. So I've got a series one plus a half, and we know it's a series because we are adding, right? We're not having semicolons separate stuff here. 1 over 4, and then plus a 9, plus an 8th, plus 13, plus a 16, and this happens to go on and on. And there comes the question. The first question, you'll pardon me, writing this will take me time. So the first question is, we want to calculate the sum of the first 20 terms of this series, okay, of the series. And we must do, there's a special instruction also which says we must do this to correct 4 decimal places. So you will notice that by the moment you take your calculator and you want to go, okay, what is half minus 1? So remember, there's 3 types we have learned now. So this thing, we can look at it, it could be quadratic, it could be linear, We just want to write all the possibilities. Okay, what happened to my whiteboard? There it comes. It could be linear, and we also learned about the geometric. So it could be one of these three, right? Not all, one of them. So we need to first satisfy ourselves that we are dealing with the right sequence. Okay, we must first start there. That will always be our starting point. What type of sequence is this? All right, is it what we want? Are we dealing with the right thing? Once we establish that, then we know the formulas. We will actually be able to pick the relevant formulas on our information sheet. So what is the test for quadratic? Well, the test for quadratic says you should check the first order of differences, right? And by the time you get to the second order of differences, you must get the same number. This is the picture of a quadratic sequence. This is the behavior of a quadratic sequence. If this is truly a quadratic, then that must happen. Remember, in this instance, we are not really told whether it is quadratic or not. Okay, so you're gonna take your calculator or whatever you wanna use, and then you're gonna just do that quick test and check whether this is quadratic or not. If it is not quadratic, we're gonna check, is it linear? If it's not linear, we're gonna check, could it be geometric? And if it's not geometric, I'll tell you now what the option is. So you're gonna go into your calculator. Okay, let me see, what is a half minus one? See, I'm trying to show you, it's like literally step by step. We're gonna take baby steps. For those who are fast, pardon me. And then 5 minus a half, we are checking 5 minus a half. Okay, that's 9 over 2. Let's write the 9 over 2. 9 over 2. Then we're gonna try again. Let's see, what is 1 over 4? And you see, I'm using a calculator because I wanna be absolutely sure. I don't wanna doubt my mental math as well. I wanna be absolutely sure that I'm getting the right computations here, the right numbers. So that's a negative 19 over 4. Okay, that's fine. We know the first order of differences is usually not constant. And I'm sure someone is already seeing that this is ain't no way quadratic. Fine, that's good. So if I do 9 over 2 and I subtract, watch this now, I subtract a negative half. So very, very important here. If I do this, I get a 5. Okay. Are we going to get a 5 when we do a negative 19 over 4? Watch this, minus a 9 over 2. I mean, this is a negative number to start with. So there we get a negative 37 over, what was that, a 4. Surely this is not quadratic. Besides, do we do the sum of a quadratic in grade 12? No, at least not in grade 12. So that could be another fact that takes you out. I mean, that makes you eliminate quadratic. That's if you are very much well aware of your examination guidelines and what is being stated there. Okay, let's check our second option. Our second option is linear, but I mean, when you do a half minus 1 and a 5 minus a half, surely you're not going to get the same answer. That one you should actually be able to pick it by inspection, that there's no way this thing is going to be linear. Okay, a half minus a 1 is a negative half. On the other hand, a 5 minus a half is 4.5. So negative a half and a 4.5, two different things. So this one is not linear at all, because in a linear sequence, we expect to get the same number here and the same number here. And so by inspection, you can tell this is not making the cut. And you could also see, I mean, if we're going to do the test for geometry, a half divided by 1 is a half. Remember, for geometric, we are looking for the constant ratio. Now, I must get the same number as doing a half divided by, I mean 5 divided by, my apologies, 5 divided by half. And surely I'm not going to get that. A 5 divided by half is a 10. So again, I've got a problem. This is no way geometric. So it's not geometric, it's not arithmetic, it's not quadratic. What is it? Well, you look You zoom in again. You don't give up. You don't leave it and say, nah, this examiner is playing us dirty. So we know, I mean, this is impossible. We're going to get free marks for this. There's an error in this question. No, well, that's not how we're going to play, right? So what we're going to do is, and I see a very brilliant suggestion here on the chat, what we're going to do is the following. We're going to notice that, hang on, if I look at the first, the third, and the fourth, there seems to be a pattern there. So yes, very much spot on. You look at your whole numbers or natural numbers, if you like, you notice that for these ones, there is surely a pattern. In fact, what we can do, maybe to try and make this much neater,